Welcome guys! Today we're going to be proving that any number in the form of 7 to the power of 2n minus 5 to the power of 2m, where n and m are any integer, is going to be divisible by 24, using the methods of modular arithmetic. So first we have to take some notes about our initial conditions. When we see that this number is divisible by 24, 24, remember, is a number with a lot of factors. So that means it also has to be divisible by something like, 2 and 3 and 4 and maybe several more combinations. But I think two very nice modular to choose here are 4 and 6. If it's divisible by 24, this is divisible by 4 and divisible by 6. And you will see later why these are good modulars to choose. But let me write this down here. That divisible by 24, we just have to prove that 7 to the 2n minus 5 to the 2m is congruent to 0 mod 6, so divisible, and that it is divisible by 4, congruent to 0 mod 4. Alright, that's good. And the second thing to note here is that the powers of this number of 7 and 5, 2n and 2m, will always be even. For any integer that has the form 2 times an integer, it will have to be even because it'll always be divisible by 2. So just note that. Powers are always even. Okay, and with that noted, we can begin by proving these congruences. And we can do that by examining the numbers in their respective modulos. And now I hope it makes sense why I chose 6 and 4, because if you look at 7 and 5 mod 6 and 7 and 5 mod 4, they should all bring numbers close to 1, which will hopefully diminish our need to work with the powers. If you don't follow, look at this next step. So note that 7 is congruent to 1 mod 6, and 5 is congruent to, 5 mod 6, but we can always write it as negative. So negative 1 mod 6. And that is very nice because now we know that 7 is the same as 1 in the mod 6 world, and 5 is the same as negative 1. We can substitute 1 and negative 1 into this statement we're trying to prove. So for the next step, we're going to use substitution and say that 1 to the power of 2n minus 1 to the power of 2m is congruent to 0 mod 6. And look closely, this is in fact true. 1 to any power 2n is always going to be 1. And here we have minus 1 to any, remember, minus 1 to any even power is going to be positive 1. And like we said here in our second note, the powers will always be even. So this minus 1 to the power of 2m will have to be 1. And y minus 1 is obviously 0, and 0 is congruent to 0 mod 6. So that's perfect. We just proved that 7 to the 2n minus 5 to the 2m is in fact divisible by 6. And to finish off the proof that it's divisible by 24, we have to do the exact same thing for the modulo 4. And it's not that different, actually. So let's do the same thing here. Consider 7 and mod 4. We get 7 is congruent to, seems like 3 mod 4. And 3 mod 4 is the same as minus 1 mod 4. And now look at 5. Well, 5 is easy. 5 is congruent to 1 mod 4. And just like in the previous mod 6 world, we can use our substitution and get basically the same thing. Look at minus 1 to the 2n minus 1 to the 2m is congruent to 0 mod 4. And using our same notes for negative even powers, we in fact get that 1 minus 1, which is 0, is congruent to 0 mod 4. And we are basically done by saying that 7 to the 2n minus 5 to the 2m is congruent to both 6, 0 mod 6, and to 0 mod 4, meaning it's divisible by 6 and by 4. It has to be divisible by 24. So, from these two proofs, we can say that 7 to the 2n minus 5 to the 2m is congruent to 0 mod 24, which is what we had to prove. And that is it. Thanks for watching.